In 1.6, we're going to cover midpoint and distance in a coordinate plane this time. Before we get going, we have another math humor. And the question is, what is the hidden math term?
The answer is it's a square root.
Oh, that's so funny. So again, we're going to start you off. We have 3 warm-up problems that we would like for you to do. It's all on the 1.5 material. So go ahead, pause the video, try these out, and come back. We'll have some answers ready for you. So here we go, take a look at the first one. It said find the length of a rectangle with a width of 14 and a perimeter of 96. We're dealing with a rectangle, and they gave me perimeter. So make sure you write down the perimeter formula for a rectangle. P equals 2L plus 2W. And then we fill in what we know. We knew the perimeter was 96. We knew the width was 14. We're solving for the length. So once we do that, we multiply the 2 and the 14, and we subtract it from both sides. We get 68 equals 2 times the length. And divide by 2, our length is 34. So since we're working with 34, length was just units. Number 2, we needed to find the area of a triangle with a base of 12 and a height of 7. So the area formula for a triangle, you need to write it down. It's base times height divided by 2, or 1/2 base times height. And plugging in what we know, the base was 12, the height was 7, and we're dividing it by 2. So 12 times 7 divided by 2 ends up giving us 42. But since we were looking for the area, it is going to be units squared. The third and last warm-up problem said find the radius of a circle with an area of 36 pi. So our area formula for a circle is pi r squared. They told us the area was 36 pi. We're throwing that in there, and that equals pi r squared. To get the pi's away, we divided by pi, and then we square root. So make sure when you square root that 36, you end up getting 6. But we talked about the plus or minus 6. It doesn't make any sense for us to have a negative for our radius. Therefore, it was just 6 units. So now we're going to talk about the coordinate plane. A coordinate plane is just basically us taking 2 lines, putting them together. The first line we're going to talk about is our x-axis, and our x-axis is this horizontal line right here. When we take the horizontal line and we cross it over with this vertical line, the vertical line is our y-axis. It ends up making a plane. So we've got our coordinate plane. And when you intersect your x and your y-axis, you end up getting this little point right here. And that little point is our origin. We call it the origin, and that's our starting point for everything. And that's the point 0, 0. Now, when we have this coordinate plane, the x and the y-axis, they intersect, and they end up splitting the whole entire plane into 4 different sections. These sections are called quadrants. And we name those quadrants using Roman numerals. Roman numeral 1, where do I start? Well, hopefully you remember from your previous math class that you always start in the upper right-hand corner. So, quadrant 1, quadrant number 1 starts off there, and then we rotate counterclockwise. So that's quadrant number 2, 3, and then 4. So we've got 4 quadrants. Remember, when you're talking about points in the coordinate plane, we use ordered pairs for the coordinates. And every ordered pair details what the x value is and what the y value is. So an ordered pair has both an x and a y, and that tells us exactly where we should plot our point in our coordinate plane. For this example, what I would like for you to do is I would like for you to plot the following coordinates. And you're going to do so on the plane. So I want you to plot RST on your own. Pause the video. And when you've got it plotted, go ahead, start it up again. So hopefully you have your points plotted in the same exact spot as I do. Let's take a look. R, it was -2, -3. So the -2 represented the x. Since it was negative, it meant you were moving left from the origin 2 units. And then it was -3 for the y. So it was down 3 units. Always do x first, then your y. S, it was 1, -4. So you move right 1 unit, down 4 units. So that's where my S is. And T was 0, 2. 0 for the x meant, hey, you're not moving left or right any. And then all you're doing is just moving up 2 units. Very important thing. When you are plotting on your coordinate plane, make sure to label those points. So I need to see those values. Oh, not values. Those are called letters. Duh. So let's go ahead and reverse this on you. Find the coordinates of points A, B, and C. And what we're going to do is you're also going to tell me then what quadrant those points lie in. So go ahead, pause the video, come back at me when you got the answers. So for point A, I ended up getting 3, 4, because starting from the origin, I moved right 3 units, and then up 4 units. Remember, always do X first, then Y. For point B, well, back her up. Let's talk point A for a second, because I remember, it said name the quadrants of the points. So, point A is sitting actually in quadrant number 1. So we're going to put Q1 down. Let's go to B then. For B, I notice, I move right, that would be a left. I move left 2 units, so that's why it's a -2. And then I notice I'm not moving off of the x-axis, I'm not moving up or down, therefore the y-coordinate is 0. The question with this is, what quadrant does it sit in? Yeah, it doesn't sit in any quadrant. It actually sits on the x-axis. Trick question. Next one, for C, the last one we've got here, starting at the origin, I move left 1 unit, so that's a -1 for the x, and then I move down 2 units for its -2 for the y. This is actually sitting in quadrant 1, 2, 3. It's sitting in quadrant number 3, so we're going to put down Q3 for that one. The next example asks you, does the line y equals 3x plus 2 contain the point 1, 4? So to begin to answer this question, we take a look at this point. Remember, with this point, you have both an x and a y value. That means that if I'm interested in whether or not this point sits on this line, all you have to do is take this x value and shove it in for the x, and this y value 4 and shove it in for the y. So we're going to do that. So we said 4 equals 3 times 1 plus 2. Now, what it is if this ends up being a true statement, then yes, the point sits on the line. If it does not equal each other, then it does not sit on the line. So I don't do anything to the 4. I'm not moving anything over. All I'm doing is just simplifying it down. I get 3 times 1 plus 2 gives me a 5. Does 4 equal 5? No, it doesn't. Of course not. So then we would say, no, that point does not sit on the line. If it was indeed equal to each other, then yes, we would say it would sit on the line.
All right, you guys, now we're going to talk about the midpoint formula. If you remember, our last time that we talked about a midpoint, we were really just dealing with one dimension. We were talking about a number line. We were talking about 2 single points. And to find the midpoint between 2 single points, you just added them and divided by 2. Remember, I talked about that average. This is a little bit different because we're no longer dealing with one dimension. We added another dimension onto it. We not only have an x, but we have a y as well. The midpoint formula follows the same type of idea. It's just now, instead of just taking one group of numbers and dividing it by 2, you'll have to compensate for the other axis. You'll have to compensate for the y-axis. So what you're going to do is you're going to take your x's, add them and divide by 2. Take your y's, add them and divide by 2. And that will give you your new point, your point in the middle, your average point, your midpoint. Okay, so for example, find the coordinates for the midpoint of VW. Well, if you take a look here, V is at 3, 6, down here, and W is at 7, 2, up here, and they want to know what the midpoint is. Now remember, we're dealing in 2 dimensions, so you have to take your x's, add them and divide by 2, take your y's, add them and divide by 2. Alright, so we need to take our x's. The x coordinate for V is actually going to be 3, and for W is going to be 7, so 3 plus 7 divided by 2. And then the y coordinate for V is -6, y coordinate for W is 2. Add those, divide by 2. So 3 plus 7 is 10 over 2. -6 plus 2 is -4. So your actual point here, the midpoint, is going to give you 5, -2. All right, the last formula we're going to talk about is everybody's favorite formula. Again, this is going to follow you the whole year, so get used to it. You're going to be doing a lot of distance formula. Okay, this comes back from your algebra, pre-algebra classes, probably even from middle school. The distance formula is the square root of the x-coordinates, the difference of the x-coordinate squared, and then the difference of the y-coordinate squared. This will find the length of a segment. Okay? So the one example that we're going to do deals with this baseball field. It says the 4 bases on a baseball field form a square, 90-foot sides, so from each to each base is going to be 90 feet. The catcher throws the ball from home plate to second base. So we're here, and we're throwing all the way to second base. They want to know what's the distance of the throw to the nearest 10th. Well, this is your first coordinate, H. This is your second coordinate, S. I want to know the distance. you're going to use your distance formula. Alright, what I like to do is actually label my coordinates, x1, y1, x2, y2. So let's do x1 and y1 down here, x2 and y2 down here. This makes it a little bit easier to plug it into the formula. So the distance is the square root. Let's do x2 minus x1. My x2 over here is 90. My x1 over here is 0. So that's going to be 90 minus 0 squared. And then y2 minus y1. y2 over here, y1's over here. So 90 minus 0 again. Order of operations, what comes next? You should know that you should do your parentheses first. So 90 minus 0 is just 90 squared plus 90 squared. Order of operations, what comes next? You have to square it, so you're going to use your exponents. So you get 8100 and 8100. When I add these together, I get 16,200. Then all you have to do is take the square root. Remember, you guys, we are working with nearest tenth. So when you take the square root, it's about 127.3 feet. All right, last example, you guys. Use the distance formula to find the length of RS. So I give you these 2 points. Please label them x1, y1, x2, y2. Plug it into your distance formula, solve, round it to the nearest tenth, and we'll see if we come up with the same answer. Alright, you guys should have labeled x1, y1, x2, y2, plugged it in. What happens is you end up with the square root of 72. Now I did this 2 different ways. The first way is I broke down your radical, which is something that you should be familiar with. 72 has a perfect square inside of it. It is 36 times 2. The square root of 36 gives me 6, and your radical 2 is left over. Now, you didn't have to have this down. I just wanted to kind of sort of show you. The actual answer, if you use your calculator, the square root of 72 is about, or approximately, that's what these squigglies mean, 8.5. Make sure you have your whisk ready for tomorrow.